Okay, so our next form of finding the system to the equations are substitution. So with this method, we're going to have our two equations and we're going to substitute one in for another variable in order to solve for both variables. So for the first one, we have the equation 5x plus 3y equals 7 and y equals 4. And remember, just like when we were doing graphing, these are both lines. So we're trying to find the point of the intersection. So we have to solve for x and we have to solve for y, and then that point is going to be the coordinate where those two lines would intersect on a graph. So if we look here, when we substitute, we are getting a variable completely by itself, and then we're going to plug that in to the other equation. So for example, here we have y equals 4. So y is the same thing as 4. So what I can do is, in my other equation, instead of writing y, I'm going to write 4. So you don't write 4 and y, you just put 4 instead of writing y. So it would look like 5x plus 3, and the 3 and the y are being multiplied. So we're going to put parentheses, but instead of writing y, we're going to write 4 because y is the same as 4, or y is equal to 4. And then everything else stays the same. So again, all we did was substitute y equals 4 in for y. Then from there, we can just solve our equation. So 5x plus 3 times 4 is 12 equals 7. And subtract 12 from each side. So you get 5x equals negative 5 divided by 5. So x equals negative 1. Now in this case here, we're done. We have our x and our y. So we have to write it as an ordered pair. So x is negative 1 and y is 4. So if we were to graph these two lines on the graph, they would intersect at the point negative 1, 4. So I want you to go ahead and pause the video and you're going to try the next problem on your own. So you have 2x plus 5y equals negative 4 and x equals 3. So you're going to take that x and substitute it in for 3 and for x. Now this one here, same concept. We have x completely by itself. So we have x equals 2y minus 3 and 3x minus 7y equals negative 14. And again, these are both equations of lines. So we are looking for that point where they intersect at. So same thing, I have x equals 2y minus 3. So instead of writing x, I'm going to substitute x into the first equation. We're going to plug in 2y minus 3 instead of writing x. So you don't write x and 2y minus 3, you just write the 2y minus 3. Now, since we have more than one thing that we're going to be multiplying by, we have to put parentheses around it so we can make sure that we're multiplying the 2y and the negative 3 by the 3 on the outside. So we're going to put those in parentheses. So 2y minus 3. Then everything else stays the same. So minus 7y. So your safest bet is anytime that you are putting something into the equation to just put parentheses around it. Then from here, we're going to distribute. So 3 times 2y is 6y, and 3 times 3, negative 3, is negative 9. And then minus 7y equals negative 14. And then this should just be a nice simple equation that we should be able to solve. So 6y minus 7y, combine like terms, you get negative 1y minus 9 equals negative 14. Then add the 9 over. So you get negative 1y equals negative positive 5, negative 5. And then divide by negative 1. So you get y equals a positive 5. So that's y. Now in this case, we weren't given right off the bat what x equals. So there's two ways you can do this. You can plug it into either equation. You can plug y back in and solve for x. You will get the same answer. However, the one that already has x by itself, that's the one that's going to be the easiest. So we're going to take our 5 now. So y equals 5. So I can substitute that in for y right here. So we're going to take x equals 2 times y is now 5, and then minus 3. So all we did was substitute the y that we found back into the equation. So then x is going to equal 2 times 5 is 10 minus 3, so x equals 7. And then lastly, our final answer is going to be written as an ordered pair. So x is 7 and y is 5. So again, if we were to graph those two lines, that's where they would intersect. So I want you to go ahead and pause the video, and you're going to try this one on your own. And then lastly, we have this problem here where we have 10x plus y equals 35, and we have 4x minus 7y equals negative 23. If we look back at the examples we have done earlier, x or y was by itself. It doesn't matter which one you get by itself, you have to look at the equation and pick out which one is going to be the easiest to get by itself. So really, if there's anything in front of the x or the y, you want to avoid getting those by itself. What you're looking for is a 1 or a negative 1y, or a 1 or a negative 1x. Some cases you might have to do the fraction, but you want to avoid having fractions at all costs. So we're going to take this first equation up here, 10x plus y equals 35, because right off the bat I can tell that this has a 1y, so I can solve for y. Because in order to substitute, you have to have a variable completely by itself, so it has to either say x equals or y equals. So from here, you're going to solve for y, so we're going to subtract the 10x over. So you get y equals negative 10x plus 35. Now that I have y completely by itself, I can take it and plug it into the other equation for y. So that's going to give us 4x minus 7 times, instead of writing y, we're writing negative 10x plus 35 equals negative 23. So all we did was write in that 10x plus 35 and for y. Then from there we just have to solve. So 4x, distribute the negative 7 through. So negative 7 times negative 10 is a positive 70. Negative 7 times 35 is negative 245 equals negative 23. Then combine like terms and we get 4x, 74x minus 245 equals negative 23. Add 245 over, and 74x equals 222. Then divide by 74, so we get x equals 3. Now again, we have to find x and y. And if we look over here to the left, we have 3 equations. We've got 1, 2, and 3. So we have to figure out which one's the easiest one to plug in, and it's going to be the one that's already by itself, or that one that we solved. But again, you can plug it in for any, you can plug x in for any of them, you'll still get the same answer. So we're going to take y equals negative 10. Instead of writing x, we're going to write 3, and then plus 35. Negative 10 times 3 is negative 30, plus 35, and so then negative 30 plus 35 is positive 5. And then lastly, write the answer as an ordered pair, so x is 3, y is 5.